Today we're going to be doing 10.3. This is on page 612 in your book. It's simplifying radical expressions, nothing too crazy. So if you look on example 1, page 612, the first example is multiplying two roots. So we have square root of 3 times square root of 5. That can just be multiplied, so you have square root of 15. Example B is square root of 21 times square root of x. Just going to be square root of 21x. Let's see. Okay, let's look at example 3. We have cube root of 4 times cube root of 8. Nope, kidding. Cube root of 2. Cube root of 4 times cube root of 2. So we have cube root of 8. Well, we can simplify that, so it's just 2. Okay, so D, we have 4th root of 5y squared times the 4th root of 2x to the 3rd. So you can multiply those together. This 5 and this 2 are not attached to any exponents under the root sign. So you're going to have the 4th root of 10 now y squared, and this is x to the 3rd. Okay, last example. Make sure this is all fitting. Okay, last example is square root of 2 over a times the square root of b over 3. Okay, so you can actually just combine these together right under the square root sign. So you have the square root of 2b over 3a. Okay, so go ahead and press pause and do practice 1, which is A through E. All right, so for A, you should have gotten square root of 35. B, you should have gotten square root of 13z. For C, you should have gotten 5. D, it's going to be cube root of 15x squared y. E should be square root of 5t over 2m. And finally, F should be, oh, kidding, that's it. There's no F, just through E. All right, let's move on. Okay, example 2 is the quotient rule. So if you have the square root of 25 over 49, that can be simplified to the square root of 25 over the square root of 49. Well, we know what the square root of 25 is. That's 5, and we know what the square root of 49 is. That's 7, so you just end up with 5/7. Okay, that's A. Let's look at B. So B says the square root of x over 9 can be rewritten as the square root of x over the square root of 9. You know what the square root of 9 is, and that's 3. So we end up with the square root of x over 3. All right, let's look at C. C is the cube root of 8 over 27. Okay, that can be simplified as the cube root of 8 over the cube root of 27. Well, we know the cube root of 8 is 2, and we know the cube root of 27 is 3. So simplified to 2/3. And our last one, example D, is the 4th root of 3 over 16y to the 4th. Okay, So this one can be simplified as the fourth root of 3 over the fourth root of 16 y to the fourth. Then you can simplify it again. Let's look, the top can't be simplified, so that just carries over. But let's look here at the bottom. You're taking the fourth root of something y here to the fourth. So that just goes away. So you're just left with y. Now, what's the fourth root of 16? It's 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So our fourth root here is 2. So you're left with the fourth root of 3 over 2y. Okay, press pause, please, and do practice 2, A through D. All right, so practice 2 answers. For A, you should have gotten 6 over 7. B, we have square root of z. That's a z over 4. For C, we have the cube root of, well, it is, never mind. It is the cube root of 125 over 8, which simplifies to 5 over 2. Okay, D, you're dealing with fourth root here, so you're going to have the fourth root of 5 over 3x squared. Now, in looking at that one, it was 81x to the 8th, and you can take that x to the 8th down to x squared by canceling out with the fourth root. Okay, let's move on. All right, example 3. All right, so now we're going to simplify square roots. So for A, we have the square root of 50. So that can be simplified to the square root of 2 times the square root of 25. Well, we know what the square root of 25 is, right? It's 5. This one can't be simplified. So our answer then is 5 times the square root of 2. It's not showing up. Let's see. There we go. Okay. All right. B, we have cube root of 24. So that can be simplified to the cube root of 8 times 3. We know what the cube root of 8 is, right? Actually, before I do that, let's separate it out here. Cube root of 8 times cube root of 3. So now we know what this is. It's 2, and this one can't be simplified anymore. So 2 times the cube root of 3. All right, C is 26. So for C, we have square root 26. And this can't be simplified anymore. There's no perfect squares that fit in here. We can't break it down. So that's as low as it goes right there. Okay, so for D, we have the fourth root of 32. So this can be simplified as the fourth root of 16 times 2. Write it separately now. Fourth root of 16 times fourth root of 2. What is the fourth root of 16? It's 2. This one can't be simplified anymore, so you have 2 times the fourth root of 2. All right, press pause and do practice 3. All right, answers for practice 3. Square root of 98 can be simplified down to 7 times the square root of 2, because before it was here, it was square root of 49 times square root of 2. So that's how they broke it down right there. The next one is cube root of 54, which can be broken down into 3 times the cube root of 2. C, we have square root of 35. Can't be broken down anymore. And then for D, we have fourth root of 243. I'm not going to give you any this hard on your test, which can be broken down to 3 times the fourth root of 3. Okay? All right. Down there at the bottom, on page 614, is a little chart that shows perfect squares, perfect cubes, and perfect fourths. You might want to put a little sticky note on this page 614, so that you can reference that page easily. It will save you a lot of time when you're trying to do some of these calculations. All right, let's look at, now we're on the top of page 615, example 4. Okay, A is square root 25x to the third. Okay, so how do we simplify that? So we're going to break it up. Square root of 25 x squared times x, okay? So let's take a look at this. By breaking it up this way, we're square rooting a perfect square here, which is 25, and we know that goes down to 5. And now we're square rooting, taking the square root of x squared. So when you square the square root, it goes away. So we just have 5x. And so this here is still under the square root sign. So we have 5x times the square root of x. And that's how you're going to break that one down. Okay, so on B, we have cube root of 54 x to the 6th, y to the 8th. All right, so how are we going to break this one down? Well, what are some of our cubes? If you look back on the page before, you can see perfect cubes and perfect squares. And one perfect cube we have is 27. Well, 27 times 2 is 54. So we're actually going to break that down into 27 times 2. Now let's look at this 6. So we're going to keep it, x to the 6th. We're going to break y down. That is a 6, although it doesn't look like one. X to the 6th. Okay, we're going to break y down to y to the 6th times y squared. Okay, and all this is under the cube root. Okay, so let's see what we can do here. All right, so on this side, we're going to put things that can be perfect cubes, and on this side, we're going to put the stuff that doesn't really fit. So let's rewrite it into cube root 27, because it's a perfect cube. 2 is not. We're going to put it over here. Okay. X to the 6th, yes. Y to the 6th, yes. And y squared is going to go over here with the 2, because it is not something that is a perfect cube. So if we break that down again, we're going to have 3 times cube root of, we're going to have cube root of 27, x to the 6th, y to the 6th, times the cube root of 2y squared. This is the same process that we were doing up here and on previous examples. We just have more variables this time. Okay, so let's take the cube root of all of this, because it will break up perfectly. All right, so cube root of 27 is 3. Cube root of x to the 6th is x squared. Cube root of y to the 6th, y squared. Now, we're going to put all of our stuff here under this cube root house that doesn't break down. 2y squared. And that is your final answer. Okay, last example. Example C is fourth root of 81 z to the 11th. Okay, so we're basically going to use the same process we did last time. All right, so we're going to have the fourth root of 81, which we know that 81 is a perfect fourth. 3 to the 4th, so we're going to leave that right there. We don't have to break it up at all. How about this z to the 11th? We can break this down to z to the 8th, because that'll go in there twice, and multiply it by whatever's left, z to the 3rd. Okay, so let's break down our perfect fourths here. So we have 3 z squared times the 4th root, that is 4, the 4th root of z to the 3rd. Okay? All right, press pause and do practice for A through C. All right, so A, you should have gotten 6z to the 3rd times the square root of z. All right, B, you should have gotten the cube root of 30. Well, that is I'm writing the problem again. Hold on, let's just write the answer. Speed it up. Okay, for B, you should have gotten 2pq squared times the cube root of 4pq. For C, you should have gotten 2x to the 3rd times the 4th root of x to the 3rd. Okay? All right. Go on to part 2 of this video, and we will do examples 5, 6, and 7, and then that is it.